Ta-da! You know what? I've set this stream up all wrong. I'm not with it. So there's going to be a little bit of a lot of a delay between the things that I say and the stuff that actually appears on the screen. Wow. Yeah, I put it on normal latency instead of ultra low latency, but never mind, let's not worry about that. So yeah, apologies for the some of that music was a little bit weird. I literally go to incompetech.com and I choose random music, and I don't know what it sounds like until I hit the play button, and at that point I'm pretty committed. So there's that. Only 20 viewers and only 8 likes. Yeah, I mean I guess it's early on a Friday, right? This one's going to be a little bit shorter than normal because there's not an awful lot that I need to teach you. I just need to give you sort of a quick recap of some of the stuff that you did in Year 9 and introduce you to a couple of things, couple of points that might trip you up when it comes to looking at logic gates. And then I've got a couple of worksheets which you might already have discovered, you might already have completed, but who knows? So let's find out. Right, so here we are. Logic gates. Yes. By the end of this lesson, right? So last lesson we were looking at the concept of logic, right? As in how to use logic in order to solve problems, eliminate certain circumstances, and reach conclusions, draw inferences, and things like that. We're now going to draw down to look at how logic is handled actually inside the computer. Okay, and by the end of this, you might have an understanding of exactly how all of those tiny little transistors inside the CPU are organized in order to do maths and stuff, because you can do some maths with these logic circuits. Okay, so we're going to learn about those. There are 3 basic logic circuits that you guys need to know about: the AND gate, the OR gate, and the NOT gate. However, I'm going to teach you more than just the bare minimum, because that's what good teachers do. We're also going to have a look at these things called truth tables. The exam board loves to put truth table questions in the exam, and if you know what a truth table is, they are super easy questions to get tons of marks on. Okay. Now, towards the end of this session, we're going to start looking at compound logic gates. And you know those maths problems, right? Where you're like, well, you know what? I can take x squared plus 3 minus 7y, and I can calculate all of that, no problem. But if you give me a question where it says John has 57 apples, and he wants to know the curvature of his new avocado. Those sort of like real world situations tend to throw people off, so you'd be pleased to know that I've got a worksheet filled with those. Yeah, I know you love it. Right, so if you didn't get this in Year 9, do not panic. If I remember rightly, Ollie, I didn't teach you in Year 9, but I do now. So you should know it by the end of this. Now, to start off with, there is a website which you've probably seen before, which is this, binary.666.co.uk. I will show it. I'll show it on the screen. Show you what it looks like. It looks like this. Okay. I've set this website up so that is that actually nope. It is not scrolling. Nothing is changing here. It's doing that thing again. It's doing that thing again. Bear with me 1 second. I just need to sort this out. No, we don't want that. We want that. Okay. There we go. Right, it's working again now. I've set this website up so you can't click on these checkboxes for the outputs. You can only click on the checkboxes for the inputs. Okay, so if I click on this checkbox here, it turns that input on. Okay, if I click again, it turns it off. If I turn them both on, you can see the output from the AND gate is on. Now, these different gates have different combinations that produce an output. So the whole point of this web page is so that you can see what output you get from given inputs. Okay, you can see if the input to a NOT gate is turned off, the output is turned on, and vice versa. Okay, so I will post I've already posted a link on the Google Classroom, but for those of you in the stream, .666.co.uk, you can see there. There's a game at the bottom, right? There's a game at the bottom, and it keeps track of your score, right? And it's not hard to cheat and give yourself extra points, but that's not really the purpose of it all. I created this website in the space of about half an hour. Okay, don't judge me. If I had more time, I'd go back and I'd make it a little bit better. Okay, so to start off with, what I'd like you to do is I'd like you to go to this website and I'd like you to experiment with the different gates, just to remind you of how these things work. Okay, so on the left hand side, these are the inputs that go into the gate. Something happens to the transmission, if you like, and then it spits out an output. You can have multiple inputs, but there's only a single output. Okay, so you try those different combinations. When you think you are ready, you can move on to have a go at the challenge. Okay, there's even a story mode there as well, so it gives you a little bit of a story. Yeah, this is me trying to make my lessons entergaging. That's entertaining and engaging. Not my word. So the idea is that each of the inputs has a checkbox down the bottom. What you need to do is turn on the things that you think are needed to give you an output here before hitting the pull lever button. So if you think, oh, I'll turn that one on and then pull the lever, oh no, the machine makes a grinding sound and the door remains closed. But we can see that this is an AND gate, right? So in order to get an output, we have to turn both of them on and then pull the lever. Well done, you earn 10 points. Okay, and then it takes you on to the next thing. Okay, so I just want you to spend about 5 minutes or so just having a play around with that, refamiliarizing yourself with those logic gates, and then we'll move on to have a look at truth tables in about 5 minutes. In the meantime, does anyone have any questions about what we're currently looking at? Look at this, it says latte on there, and I'm drinking orange juice out of it. Milk chocolate. No, not for me. Orange juice. That's anarchy right there. Okay, so if there's no questions about that, I'll give you about 5 minutes. And obviously, I want to find some. Find a tune that's gonna help you. Let's search for calming. Do you want a calming tune? Um, The Sky of Our Ancestors, this tune is called. So obviously, if you don't like the music, you can always turn the volume down. This track is a few minutes long, so when it gets towards the end, we will pick up and continue. There we go. Yeah, no joke. Yeah, I muted my thing for some reason. Right. Anyway, I'm unmuted now. What I was going to say was the NAND gate. Right. It's a not AND gate. So you see the little circle in front of the gate there. That is actually the little circle on the front of the NOT gate. It's like if you got a NOT gate and just pushed it into the look, I'm not muted anymore, guys. I can see my mic levels are I can see my mic levels that are, I mean, you can keep on telling me I'm muted, but you're wrong, you know. Maybe you guys are just too far behind in the stream, you know. Maybe you just need to sort of like catch up a little bit. I don't know. I was muted for a time. I'm now not muted. All right. So anyway, as I was saying, NAND gates, not AND, right? So you have an AND gate and then you have a NOT gate in front of it. So the NAND gate is on any time an AND gate would be off. Okay, so remember, an AND gate is only ever on when both of them are on, which means a NAND gate is only ever off when both of them are on. All other times it is on. Okay? I mean, people are free to dislike the stream if they want, you know. If it makes them feel better about themselves, that's fine. That's fine. Yeah, I know there's a lag on the chat. It's because I didn't set it up to ultra low latency, and I can't change it. Can't change it once I'm going, unfortunately. Anyway, so we're ready to have a look at the next bit. You're all sort of familiar with how those different things work. Remember, the only ones that you actually need to know for the exam are the AND gate, the OR gate, and the NOT gate. But understanding these others is going to be a big help for you. Okay? So, let us move on to the next bit. Okay, you guys need to know about these things called truth tables. It's not rude to dislike. I mean, it's the whole like and dislike system is there so that people can feed into the algorithm with things that they want to see and things that they don't want to see. But the thing is, if someone dislikes a video, that's actually better for the video than if someone doesn't do anything at all, because it shows an interaction with the video. It's a very complicated thing, but I mean, if I think people, and this is not related to computer science or even YouTube, but being able to accept criticism is a very important thing, right? I'm pretty damn good at painting, okay, but I didn't get good at painting by only having people say that looks really good. I had people point at my stuff and say that looks rubbish, and I had people say I don't like that. What have you done there? Because by people saying that no, I don't like that, it makes me think, okay, well, how can I improve it? You know, just saying I don't like that, yeah, that's not particularly helpful. But if they explain why, then that can be a very useful thing. Anyway, I've got a little bit off topic. There we go. So truth tables. Let's have a look at these things called truth tables. Okay, he says, going on to the next slide. A truth table. A truth table is a table that shows you the outputs for something given specific inputs. Okay, now traditionally our inputs are labeled A, B, C, D, E, F, G, and so on and so forth. Our outputs are usually Q, R, S, T, U, V, blah 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 blah. I don't know why that's just a convention. Okay, but here's how to read a truth table. Okay, read across a column, a row at a time. Okay, we can see here for this first row, when the input into A is 0, so there's nothing going in there, and the input into B is 0, so there's nothing going into B there, we can see the output at Q is also 0. Okay? That makes sense, yeah? When the input into A is 0 and the input into B is 1, the output from Q is 0. I'm going to move the pointer off there. When the input into A is 1 and the input into B is 0, the output at Q is 0. And when the input into A is 1 and the input into B is 1, the output at Q is 1. Now, in my mind, that is so ridiculously straightforward, I barely have to explain it. But I understand not everyone thinks the way that I do. So, is there anyone that needs me to explain that in more detail, or do you understand what's going on there with the truth tables? Okay, that's the truth table just for the AND gate. Does that make sense? And they never said anything ever again. Karen says yes. One person. It makes sense. Yep. Be right back. I need to go and glass of water. Okay, cool. So, with that in mind, I'm not going to get you to do it now, because that would require me to sit here waiting for you to finish the task. But on the Google Classroom, there is a worksheet which has got all of the truth tables for all of these gates drawn out. I just want you to complete those truth tables. Okay, that shouldn't take too long. And what you can do as well is using this website. When you're completing the truth tables, you can use the switches to turn the various bits and bobs on or off, so you can see what the output is as you're filling out those truth tables. Okay? So, as I said, don't have to go and do that now, but that worksheet is there on the Google Classroom. Okay? So, let's just move on to have a look at something a little bit more complex. Okay? Compound logic circuits. This is where you have the output of one logic gate feeding into the input of another logic gate. Okay, I've got a little diagram on the board there. There are two gates on there. I'm not going to say what they are. I want you to have a look at that. And I want you to tell, there's only one instance where the output of Q is 1. I've put, when is the output of Q? That doesn't make any sense. Should say, when is the output of Q 1 and why? Okay, I want you to have a think about that, and then just pop it in the chat what you think the answer is. And while you're doing that, I'm going to go and make myself another cup of coffee because I barely slept last night. I've been having awful nightmares about there was a wasp that stole a dice. I'm not gonna go into any more detail than that, but I will go and make a coffee. When I come back, you guys will hopefully have an answer. When is the output of Q1 and why is that? Okay, remember we've got the output from that first logic gate, A and B, feeding into the input of the next one. Okay, I shall return in a couple of minutes, have a discussion, have a think, and then I will return. Ta-da! Cool. Right. So let's have a look. We've got 111, 111, evil wasp. Yes. A1, B1, C1 equals Q1. Yes. Has anyone said why? Because and needs both to be on. Yeah. I mean, if you have a look at it, right? If we have a look at this here, in order for this output here to be 1, both of these inputs need to be 1, right? And in order for this output to be 1, both of these inputs need to be 1, okay? I often find it easier to sort of start at the end and work backwards. So here's my output here. Oh, I've got an AND gate. I need both of these to be 1. Well, that goes straight to an input, so that needs to be 1. And tracking back here, I've got another AND gate. They both need to be 1, therefore, you know, A is 1, B is 1, C is 1. I mean, you could draw the truth table for that. Here's a question for you. When we had a single gate with 2 inputs, there were 4 rows in the truth table. If I've got 3 inputs, how many rows do I need on the truth table? If I've got 3 inputs, how many rows am I going to need on the truth table? I'm not muted. I didn't even mute my mic. Such lies. Any answers to that question? How many rows am I going to need? It might not be that I'm muted, Ollie. You might have muted yourself. You might have turned the volume down. We're not talking about inputs, Alex. We're talking about rows in the truth table. We've got 3 inputs. How many rows do I need on the truth table? Not 9. Although I can see where you got 9 from. It's close to 9. 8. Yes, why 8? Okay, let me put this another way. If I had 4 inputs, how many rows would I need? Look at that. It's cool, isn't it? If I had 4 inputs, how many rows? Man, next time I've got to remember to put it on ultra low latency. 16, yeah. Do you recognise those numbers? 4, 8, 16. What would the next one be? And the next one after that? And the next one after that? Do you recognise those numbers? No one recognises those numbers. $32, then 64. Yeah, these are the same magic numbers that we use in our binary calculations. They're just powers of 2. Okay. Keep going. What's after 2048? There we go. 4096. 8,192, 16,384, 32,768, 65,536. Yeah, we know all these. We know all these. Right, okay, so let's get on to the actual substance of this here, right? There is a website, Logically/demo. In fact, I will paste that in here. http://logic.ly/demo. No, we're not going to reset now. You just have to deal with it, right? There is Logically/demo. Let's go to my demo screen here. And this is what Logically looks like. Hopefully you'll all be familiar with it. It's dead easy to build circuits. You will need switches for your inputs, and you will need logic gates, and you will need light bulbs for your outputs. Okay, let's just draw this circuit here, and you can see we've got an AND gate there, right? If I wanted to build that same circuit from the previous slide, I'd have a second AND gate, I'd have a third switch in here, right? You shouldn't need me to go through and explain to you how this works. It is super duper straightforward, but you can bring you can build these different circuits. You can test them all out. Okay. You can also, and this is something I'd like you to try and get into the habit of, you can also add labels. Okay, so maybe that's going to be A there, and then let's have another label here. That's going to be B there, and another label there, and that's going to be C there. And maybe a label for our output, which is going to be Q. Okay, and we can move that over here. Let's get them looking reasonably compact there. Okay, there's a nice A and B and C circuit. Okay, now what I'd like you guys to do is, first of all, use that website to build the logic circuit for A and B or C. And once you've done that, see if you can complete the truth table. This is what our truth table looks like. You can see 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. That's just counting up in binary. Okay. If we were to add an extra input, you could continue that down. It would be 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, and so on and so forth. Okay. Anyway, what I'd like you to have a go at is producing the logic circuit for A and B or C, and then have a go at filling in that truth table that's there. Once you've done that, there is another worksheet. Now, the other worksheet, it's not a case of saying, oh, here's a circuit, go and build it, because that would be easy. Okay, this is a little bit more difficult. So let's have a look at this worksheet. Right, you need to think, what are the inputs to the system and what are the outputs from the system. Okay, so we've got an alarm here. Create a logic circuit which sounds an alarm only if the window or the door is open and the alarm is on. Right, the inputs to the system are the window open, the door open, the alarm on. So that's a switch that you turn on to say yes, the alarm is on. Right. There's also this automatic watering system. You've got inputs, moisture, light, and the outputs there. Okay. You need to think about how these different things are going to interact. Okay. Some of them might seem fairly complex, but remember, you've just got your yeah. Right. Okay. There we go. But then you just got your inputs, your outputs. Okay, they're either on, they're off. Think about how that would fit in here. Okay. There's not an awful lot more for me to say, but when you are getting your screenshots, because what I'd like you to do is create the solution using Logically and then get a screenshot. Remember, if you're on Windows, you can hold down the Windows key, Shift and S, and then drag a box around the area that you want to capture. Drag a box around it, and then you can paste it directly into your document, for instance. Okay, I'd like your I don't want full screen grabs. Try and keep your circuits reasonably concise like that. Okay, so that is basically what I'd like you to do. There's nothing more for me to tell you. I can't really teach you anything else in order to help you get through this, but I will answer a question. Does anyone have a question for me? Is there anything they're not sure of? Do you have all of the tools at your disposal to be able to complete those tasks? Yeah, I mean, you could use Snipping Tool if you're living in 2015. The shortcut was Windows Shift S. I'll put that in the chat there. Okay, so I appreciate that it's we've got quite a lot of delay on the stream today because I messed up the latency settings, but I don't think that's really affected us too much. I think most of it is all pretty straightforward. If anyone does have any questions, or if you're working through those worksheets and you want to, you're not sure about something you want to ask, I will be in the Discord chat, so you can just pop on there and ask me any questions that you have. Okay, so your 3 tasks, which you might already have completed. Number 1, complete the truth tables worksheet. Number 2, use logically to draw the circuit A and B or C and complete that truth table that's on the screen right now. And number 3, complete the compound logic circuits worksheet. All of this stuff is on Google Classroom. Okay, now, are we getting the... I have an outro. I can't remember which outro. Oh yeah, I can remember what outro it was. So Bruno, if you remember rightly, your outro had copyrighted music in it, and I asked you to redo it without the copyrighted music. Okay, I'm still waiting on that. So get me that. But I do have an outro for you. And I will use your outro as soon as you sort the music out. Okay, it's only a short outro, I'm afraid, but let's see if it works. I've got to be kind of oh man, I don't know if this is going to work. I don't know if this is going to take skill to do properly. Okay, so let's see if we can do it. Okay, so thank you very much, everybody, and I will see you all on the next stream, which is Monday period 2, I think. And send me those outros, and I'll get them all cranked up for the next one. All right.